Hello, I'm Glen McKie, and in this video we're going to look at 3 sampling methods, or sampling, depending on what state you're in, might depend on how you pronounce that. Okay, so this is within the topic of statistics. So we need to be aware that there are 3 methods of sampling from a population. And here's what they're called: simple random, systematic, and stratified. Let's work through each of those. So a simple random sample of size n from a population. Each member of the population has that same chance of being selected in the sample. Try and keep in your mind the idea of the year levels within a high school. So if you're in year 11, and we want to survey people within the year 11 cohort, how could we randomly select that sample and make sure that each one has the same chance of being selected, and that each set of n members of that population has the same chance of being selected as anybody else. And some extra examples to think about here are raffle tickets out of a barrel or Powerball numbers drawn by a spinning machine. In terms of generating random values, you can do that on your calculator. You're going to get much more out of this video if you play along with me at home. So grab your calculator. I use a Casio, so grab that there, turn it on, come on, play along with me. So using the main menu, go to Run Mode, Option, F6, Probability, Random, and then Int, standing for integers, so whole numbers. And then what you need to put in is you need to give it some instructions. So let's say you want them between the numbers 1 and 10, and you want it to produce 6. This would be what appears on your screen. And here are 6 random integers. Notice that it's possible for them to be repeated because they're random each time round. And if you cursor back up over that and enter again or hit equals, you'll notice it will generate another set of random variables. That might be a skill that you need to explain at some point in time in a test or an assignment or to somebody else. So do make sure you've practiced how to find that within your calculator. Then systematic sampling. So in this method, there's some rule that's followed to select the sample. For example, every 500th person on the electoral roll, or if it was year 11s at school, it might be every 14th person. This is particularly useful when not all members of the population are together for sampling at a single moment in time. For example, if you don't have all the year 11s in one room at a time, you might order them by their SACE numbers or their enrolment numbers, and then select systematically the 14th student or something in each group there, because they might not all be together, as in like physically in the one place. So what's an example of that? So let's imagine that management of a large city store, they wish to find out whether potential customers like the look of a new product. So they need to ask some customers. They decide that to sample 5% of the customers using a systematic sample. Now, how would they select that? So 5%, what's that as a percentage? Obviously 5, but what does that mean in terms of 100? It means every 20th person, so 1 out of 20. So that's the technique that you would do for whatever percentage is needed. Put it over 100, see if it simplifies down. And in this case, it's every 20th person that they need to sample. But how do they do that? Still randomly, but systematically. So the starting customer is selected from 1 to 20, and so a starting customer is what I mean, and they've randomly selected the number 7. Again, using a random number generator on a calculator, they could randomly select any number between 1 and 20. So it doesn't mean you select the 20th person or the first person out of every 20. You should have a random starting point as well. And so that means the store would select every 7th customer. Let's say somebody's keeping track as they walk past a counter or out of a door with that product. And which customers do they select then? So the 7th, and then 20 after that. So the 27th, 20 after that again, 47th, and so on, until they've got the required sample size that they need. And stratified sampling. Well, I'm just going to go back. Systematic sampling. What word does that sound like? I guess it's got the word system in it. So you have to have a system, like an order, technique for doing your sampling. What about stratified? It's a word sometimes used in real estate, so you might not have heard it before, but stratas is often to do with levels and things like that. So, and we use this when there are subgroups. So think in a high school, there's different year level groups. And to ensure validity, that each subgroup must be represented appropriately in the sample. So imagine the cohort of your school, and we're going to do an example on this. What if you have more year 8s than year 12s? what is the size of the sample that you should use for each. So that proportion needs to stay the same. It might mean then that the number of people is different for each cohort based on how big, but then it's still the same percentage of that cohort. Let's put that into practice. It'll make more sense. So let's say in a school, in the different year levels, there are 137 students in year 8, this many in year 9, 10, 11 and 12. This example came from a South Australian textbook prior to when we had year 7s in high school. Year 7s only joined us in, 2022. We're the last state in Australia to come on board with that. Now let's say we need a stratified sample of 50 students. Now you might look at that and go, oh, there's 5 year levels, so let's take 10 from each. But that's not a representation then, a true representation of each year level. So how many in the whole school to start with? You add up the total number in each year level, 752 students in the school. So which cohort had the most there? It's the year 10s. So if we took 10 students from year 10 and 10 students from year 12, well, 10 in year 12 is actually then over-representing the year 12, and 10 out of the year 10 students is an under-representation. So we need to work out how many in each year level. And how do you do that? You look at the number of students per year level divided by the total that are in the school and times by 50, because that's how many that we need for the whole sample. So this is the proportion of 50, and that comes to about 9. There'll obviously be some rounding that needs to happen. And so here are the other the 4 examples here, taking the population of each year level, dividing it by the total in the school, timesing it by 50 and rounding. Now, what needs to happen with each of those 5 numbers though? In total, they have to add to 50. So you just have to adjust that. You might have to check your rounding to make that happen. Okay, so here's some questions to do. Subscribe to the channel, give it a thumbs up. Thanks for joining me.